All right, so example 7 says, use the definition of a logarithm to write each exponential equation into logarithm form. So, first thing you're going to do is look at these and look at the one we did before. So, did anybody figure out how to do A? Anyone?
Is it log 5, 25 equals 2?
Good. Log base 5 of 25 is equal to 2. Good. So you see how we just worked backwards there, okay? You just worked backwards. So it's going to be log base 5 of 25 is equal to 2. So using that logic, what would B be? Log base, what? Good. 81 equals 4. Good. Any questions on either of those two? You're just working your way backwards. Okay. So let's try C and D. So if you want to look at this one as reference, what's this one going to be here? Log base what? Good. Of? Good. Equals? 4/3. Very good. And then D will be log base what? Of? 1/8 equals? -3. So you guys get the idea of where everything goes using the last few as a guide? Alright, so that's how you go back and forth. So we're just, like I said, practicing notation right now. We're not doing any calculations, we're really just practicing how it all flows together, how it goes from one to the other. So, now we're going to actually look at a few that have some basic evaluation. So, like I said, we're kind of easing our way into logs. We're not going to kind of throw it at you at once. So, do I have any questions about example 6 or 7? All right. So this one says, use the definition of a logarithm to evaluate. So these ones are going to be simple ones to evaluate, okay? So now that you know the notation, okay, these are logarithmic expressions. We're going to turn them into equations by using variables, okay? So we can set this equal to some variable. Pick a variable. I don't care what it is. X, okay. So we're going to set it equal to some variable because that's how we evaluate logarithms by hand, okay? So you set it equal to some variable, and now we use our rules that we were using earlier. So you take 7 to the x power is equal to what? 49. Now this one is easy enough that we can evaluate x. So what is the x value here? 7 to what power is 49? The second power. So x here is 2. So the value of this is 2, right? So log base 7 of 49 is equal to 2. Everybody see how we got that? All right. Let's try B. So you set it equal to a variable. We'll do x. And what's this one going to be? Log, or 3 to the what? Is equal to? So that means x must be what? Three times 3 times 3 is 27. So what's 3 to what power is 27? 3. Good. Makes sense so far? All right, let's try C. We set it equal to some variable. 5 to the x power is equal to 125. What must x be here on C? You guys still with me here? We're going to have some doubles.
Is it 3?
3, good, yep. We're going to have some longer lessons in here, and they're not always going to be half and half. This is algebra 2, so they're a little bit longer. And let's try D. So, this is 6 to the x power is equal to 1. What power do you put something to get 1 all the time?
1.
6 to the first power is 6. 0. Anything to the 0 power is 1. So in this case, did it matter what the base was? No. Could have been anything, and it would have been 0. So any questions about those questions so far? All right. Let's try E. So are you starting to get the gist of this here, how it works? 2 to the x power is equal to 64, which means that x is equal to what?
5 or 4?
6. Now something else that you can kind of do, and I'll just show you how this could work, is you could say 2 to the x is equal to, well, we know that we can put 2 to the 6th power, which means x is 6. You can rewrite this that way as well. So that's another option on how to kind of see this. All right. So 3 to the x is equal to 243. So x here would be equal to 3 to what power is 243?
4.
Not 4, but one more.
5.
5th. You can check it in the calculator. 3 to the 5th, yep. Okay. 9 to the x is equal to 1 over 81. So if you remember back to, this is a little bit tricky, not too bad. What we're going to do is we're going to ignore that this is a fraction. Okay, imagine if it was 81. What would y be, or x be, if this was just a regular 81? 2. So instead it's just 1/2. No, wait, hang on, not 1/2, sorry. Negative 2. That's what I meant to say, sorry. Negative 2, you're right. Negative 2. Yep, so if you ever have a reciprocal like this, it's negative because remember, when you put something to a negative exponent, it brings it to the denominator. And then lastly, so this one is 64 to the x power is equal to 4. This one can be a little bit tricky to figure out. So the easiest way I think to figure it out is the other way around, okay? So 4 to what power would give me 64? 3. So instead it's the reciprocal of that, which is 1/3. So 64 to the 1/3 power is 4. So there's a few different ways you can solve that one, but that's, the idea. Yes?
Oh, why do we use negative on that one and then fractions on that one?
Okay, so on this one, this number right here that has the power is the smaller number, okay? So in this particular case, if we do 9 to the negative 2 power, it takes the reciprocal of that. So, like for example, if I was just going to do 9 to the negative 2 power, that's the same thing as 1 over 9 to the 2nd power, which is 1 over 81. But over here, we're taking the bigger number and putting it to a power here. So we don't have any fractions going on in the actual numbers itself like we do over here.
Okay.
So, like over here, we could have also rewritten this as, I have it written down here. There we go. We could have rewritten 64 also as 2 to the 6th power, right? which is then to the x power, which is equal to 4, which is 2 to the second power, which would be 2 to the 6x power is equal to 2 to the second. And then since we have a common base, we could set the exponents equal to each other. And we could get x equals 2 over 6, which is 1/3. Does that make more sense?
Yeah.
Okay. Does anybody have any questions about these? Any other questions? Okay. All right. So the last thing we're going to be talking about is common and natural logarithms. So while a logarithm, let me zoom this one out. So while a logarithm can have any positive value as its base, there are two logarithm bases that are more used than any other, specifically logarithms with base 10 and base e. A common logarithm is a logarithm with base 10. So you're going to see that if the base is 10, they're not going to write a base at all. It's an implied 10. You know how in coefficients we kind of imply that it's a 1 unless we write otherwise? It's the same idea with logs with 10. So you assume that the base is 10 unless they state otherwise, which we did state otherwise in all the other problems we just did. Your calculator has a log key for evaluating common logarithms. So very specific, the calculator key only evaluates common logarithms. It assumes the base is 10. All right. Now if we do a natural logarithm, the ln button, that's basically log with base e. So it's the same idea, but instead the implied base is e, which is Euler's number, which is like 2.7 something, right? So there's an ln button for evaluating natural logarithms. So when you use these buttons, it's assuming a base of e or a base of 10. So the base is not something you can put in the calculator using that button. You have to do other things first. So just keep in mind that button assumes a base. So we're going to evaluate a bunch of what we call common logarithms. Okay, these are ones that we assume the base of 10 or we assume the base of e based on which one they're asking us about. So this is where we're going to start using the actual buttons in the calculator. Okay. All right, so let's get started on using the buttons in the calculator. Let's get some practice on that. So if we're just evaluating a log, which notice this log doesn't have a base, so it's an implied base of what? 10. So the way this one works is log of 25. So you're going to type in 25 and you're going to hit the log button. And you're going to get approximately 1.40. For B, same idea. 0.5 log button. And you're going to get approximately negative 0.30. Now let me explain what this is actually doing, right? We said that this is a common base of 10, right? So it's log base 10 is equal to 20, or of 25 is equal to x, right? So that's 10 to some exponential power is equal to 25. Well, we just found the x value, which would have been 1.4. So if you take 10 and put it in the calculator to the 1.4 power, you're going to get approximately 25. So that's the math that this is actually doing when you use this calculator. Does that make sense? Like over here, this is log assume base 10 of 0.5 is equal to x. We take 10 to the power of x, which is equal to 0.5. And if you take 10 in the calculator and put it to the power of negative 0.30, you're going to get approximately 0.5. So you can check your work doing that too. So ln, we're going to use a different button for ln. So let's just do f and g to get, like, while we're over here. So we type in 25 and then we hit the ln button. And when we do that, we should get approximately 3.22. Now with ln means a natural log, a log of base what? Not 10, but e. So that's log base e of 25 is equal to x. So if you do e to the x power is equal to 25, well, x would have to be 3.22. So then we'll do ln of 0.5. So 0.5 ln, that comes out to be approximately negative 0.69. So everybody's starting to get the idea of these, how to do them, what they mean. So this one here, log base 10. Now let's think about what this means. Log of 10. Remember, log is an implied 10, so log base 10 of 10 is equal to some variable x. So 10 to the x power is equal to 10. What must x be on this one? 1. And if you type in 10 on your calculator and hit the log button, what do you get? 1. So that's why. And what do you think this one's going to be? So ln is log of base e, right? Log base e of e is equal to x. So e to the x is equal to e. What must x be? 1. So this one is log of 0. So that's log base 10 of 0 is equal to x. So this means 10 to the x power is equal to 0. What do you think the calculator is going to do when you try to figure that one out? Error. Why is it going to be an error? Logically, why? Anyone know? Is there any possible value for x that can give me 0 here? No, that's why. And what do you think about ln of 0? None either, because it's the same idea. And then the last two, log of -1, type it in. What happens? Error. That's because this means log base 10 of -1 is equal to x. So that's x, or 10 to the x is equal to -1. You can't put something to any exponential power and get a negative number. And what do you think this one's going to be? Also an error. So you guys starting to get kind of like scratch the surface on logs, you guys starting to understand the concept?